Alright, it's me again. So let's continue where we left off. Now, I'm going to skip 3 for a second. I'm going to do number 4 and then I'm going to come back to 3 because 3 is really important and I want to really get into that. 4, now, the thing about 4 is I've noticed in the Hawks learning sometimes it was wanting this answer a different way. It says here a pilot flew a plane from an altitude of 11,700 feet to an altitude of 11,100 feet. What was the change in altitude? Well, this is just your basic subtraction problem. So you write out your numbers and you just subtract them. Now, if you do it this way, you get 600. That was the decrease. It was a decrease, okay? So I think in most cases, if you write it like that, you'll get full credit. I know in Hawks, sometimes because it is a decrease, you went down, they wanted you to write negative 600. So it's one of those cases where if you see a problem like this on the test and you're not sure because your homework was having you do it one way and you're not sure if your teacher wants you to do it that way, this is a situation where I wouldn't necessarily write this negative 600. I'd be careful. I would go and ask my instructor and say, is this what you want? If not, they might want you to write the 600 decrease or it went down 600, something to show that it decreased, okay, and that, the number 600 was involved. So it's kind of an iffy problem, but you never know. I just want to show you an example of it. And, most instructors are very nice. If you went and asked them, they have no problem telling you which one they want, okay? As long as you do the question right. So let's go back to 3. 3 gives you two examples of negative 5 squared. Now, as a teacher, if I'm in a class and I say, hey, what's negative 5 squared? My students are going to say 25. But these two ones up here actually give you two different answers. And it's because the parentheses is very important. So a lot of students make a mistake where they type this into a calculator, where if I said what's negative 5 squared and they didn't know off the top of their head, they type it in the calculator and it would come out negative 25, which is wrong, okay, whenever you say it a certain way or you're writing it a certain way. So if you see the parentheses in the second one, that's very important. If you have a calculator, you need to enter it, if your teacher gives you a problem like this, exactly how you see it, parentheses and all. So you need to know where those buttons are on the calculator that you have. In this case, this is going to be equal to a positive 25. All right, positive. That's what that POS stands for, not anything else. Knock, knock, knock. So this negative, though, this negative 5 squared right there, like that, with no parentheses, this is negative 25. And the reason why is because of the order of operations. I'm not going to get into the whole, well, the order of operations, negative, I'm not going to talk about that. I'm just going to tell you that if you see it like the first one with the green, your answer should be negative, no parentheses, and the number's negative. If it's a negative 5 squared, no parentheses, your answer should be positive. Some calculators, if you type it in just like that, it will still come out positive, not negative. It just depends. So just know that no parentheses, that's going to give you a negative answer. If it has parentheses and it's a negative inside the parentheses, like in the second one, the red one, that's a positive answer. So just be careful on your test that you're not getting something wrong because of something silly like that, okay? This is one that really confuses students, and you can't trust your calculator because it depends on which calculator you have and how familiar you are with it. But I'm telling you, if you see the first one, your teacher wants a negative answer. If you see the second one, your teacher wants a positive answer. They're not going to trick you and want the other one, okay? Move on to the next set of problems that have to do with classifying numbers. We're going to talk a little bit about each of these, okay? First one says just check all the categories that apply to this number. So number 9, like 13, it fits multiple categories, and you can have that. Some numbers just fit one category, some numbers fit multiple categories. If you remember, your teacher probably explained to you that this whole thing starts with the natural numbers. The natural numbers are whenever you were just first learning to count and learning what numbers are in like elementary school or kindergarten or whatever, is that they told you, they say, okay, it goes 1, 2, 3, and so on. Goes on. Well, 13 fits into that, right? 1, 2, 3, 4, all the way up to 13. But it starts where? At 1. The natural numbers, they start at 1. So this is a natural number, but it can also be other stuff. So we're going to check that box. The whole numbers are the natural numbers. It's 1, 2, 3, 4, 5, so on. But it also has, we add 0 to all the natural numbers. So it's 0, 1, 2, 3, 4, blah, blah, blah. So this fits in there as well. The next one are the integers. Well, about the time maybe you got to 5th or 6th grade, I know it's usually middle school, they start introducing negative numbers. So the integers has 0, 1, 2, 3, and so on, but it also has -1, -2, -3. So this has everything else plus the negative. So I didn't write add, so we add the negatives. And here's the thing, because we're adding the negatives to everything else, 13, although it's not negative, classifies as an integer. It's part of that set. Now, the next thing that we looked at was rational numbers. Okay, rational numbers includes you take everything else, negative, positive, whole, natural, and you add fractions and decimals, everyone's favorites. Fractions, I'm going to use this little symbol for and decimals, okay? Well, I can take 13, this is very important, and I can write it as 13 over 1, so I can write it as a fraction. It's a rational number. The only one it's not is irrational, okay? And actually, the next one is irrational. Before I talk about that, there are some numbers that if I gave you the number 1/3, that is just irrational. It's not anything else, okay? And if I gave you like -2, that is a rational number because I can write it as -2 over 1 if I want, okay? But it is also an integer. But it's not a natural number, it's not a whole number. So sometimes they fit one, sometimes they fit 4 of them. How nice. Just depends on the number, okay? Now, let's talk about pi. Your teacher probably gave you some really weird, long definition about irrational numbers. That irrational numbers, they might have said non-repeating, non-terminating number, and that's really hard for a lot of people to understand. Pi fits into that category, though, because if you've ever seen the decimal of pi, and you might have in a math teacher's class, it's like 3.14, and it keeps going on. It never repeats, so there's no repeating, and I'm going to talk about what this looks like, okay? And it doesn't stop. It goes on forever. There's been people who've done pi to 1,000,000 places and more. So no repeating, doesn't stop. Can't stop it, okay? So some other numbers that fit this bill are stuff like square root of 2, square root of 11, okay? Weird stuff. That if I were to punch those into a calculator, I'm going to get something that goes on forever, and it doesn't stop. So when I'm talking about this, what this looks like, let's just take a second to think about it, is the no repeating. If I give you the decimal 0.875, this stops. Because it stops, it's irrational. It's not irrational, okay? If I gave you the decimal 0.3333 and it just keeps going, repeating, and so on, this is a repeating because it's the same thing over again. And even if it was something like 6767, etc., okay? Those are repeating. Those are rationals. It's only in the case whenever you look at it, there's no repeating, like in these groups here that you see, and it does not stop. It goes on the length of the calculator. Then it fits that irrational number. Check that category, okay? So just pay attention. I don't think your teacher's going to give anything really hard in this. It'll be something like pi or square root of 2 or something. And then you could check in the calculator. They're not going to trick you and give you some weird decimal that doesn't repeat for, 8 places or something crazy, and it's not going to be like that. So it should be pretty simple for you to be able to do and figure it out, okay? So just make sure you know which ones are which. It's not the easiest thing, but just make sure you study how this looks so that you can replicate this on your exam. Let's see what we got. If I want to move on. Let's talk about this because we were just talking about decimals, and I'll try to keep this kind of short. So it says here, use long division to change the fraction to a decimal. Well, like I said, if you had your calculator, the first thing you can do is just take 17 and divide by 40, and that will end up giving you 0.425. So you can see right away what the answer is. Now, I'm not saying your teacher's going to accept that as the answer because they're not. But what they're going to do is that'll at least tell you what you need to be looking for so you know how to do this. I know long division is not anyone's favorite thing, but if you remember, it's always the bottom number into the top number, and the reason why this is a decimal is because that bottom number is bigger than the top number, okay? So that's how you know it's a decimal. So, boop, decimal point. All right. Now, 40 doesn't go into 17. That's the whole point. So what I do is I bring in a 0. And now I say, well, how many times does 40 go into 170 without going over? Well, 40 times 4 is 160, and I write that 160 there and I subtract. Now 170 minus 160 is going to give me 10. Well, unfortunately, 40 doesn't go into 10. It's still too small. So I drop down another 0. And now, how many times does 40 go into 100? Well, twice. Write my 2 up there. I write my 80 here. And I subtract again. And 100 minus 80 is 20. I'm still not over 40, so I'm still not getting anywhere here. So now I need to bring down another 0. And now 40 goes into 200 5 times. So if you notice, I've gotten this decimal 425. That helps me figure out what I need to be doing. But you have to show all this work here to get credit. Okay? Now I would write the 200, subtract, and that gives me 0. Once I get a 0 remainder, because there's no remainder here, okay, 0 remainder, I know I'm done. I don't have to keep going. But you use that calculator to help you get an idea what to do and if you're correct. But if you just write 0.425, you're not going to get the full credit. Okay, so don't even try to do that, all right? So I'm going to stop here before I get into some of the algebra, and we'll catch up with that.